Hello everyone, I'm Jennifer Francis. I'm a senior scientist at the Woodwell Climate Research Center. Thank you very much for inviting me to be part of your workshop in a small way. And I am going to talk a little bit about the connections between the changes in the Arctic and extreme weather and changes in weather patterns in mid-latitudes, which is the focus of my research. And as I'm sure you all know, the Arctic is now warming 3 to 4 times faster than the globe as a whole, which we call Arctic amplification. And this disproportionate warming should increase even further as sea ice and spring snow cover continue to disappear. One question that raises is, how does Arctic amplification affect weather patterns in mid-latitudes, especially extreme weather? This is a very active and controversial research area, with dozens of studies published since the early 2010s when the first hypotheses of a connection were proposed. It's controversial because the story is complex. Many variables are changing simultaneously and interacting with each other. It's hard to find a signal in the noisy, chaotic climate system. What's not controversial, though, is that there are connections. No one disputes this. You can't change one key component of the climate system so much and not see impacts on the atmospheric circulation more generally. I'll give a very brief summary of the state of the research by looking at winter and summer separately, because it appears the connections are very different in those two seasons. In winter first, there are two main focus areas. First, we know that Arctic amplification weakens the north-south temperature gradient between the Arctic and mid-latitudes. When the gradient is weak, the westerly winds of the jet stream also weaken, and the Arctic oscillation tends to be negative. During negative periods of the Arctic oscillation, we tend to see a wavier jet stream and more atmospheric blocks. These tend to cause extreme weather of various sorts. We also observe that when the Arctic is unusually warm, cold air outbreaks and snowstorms are more likely around the northern hemisphere. The second focus area is figuring out the role of the stratospheric polar vortex in all this. The vortex only exists in winter, unlike the jet stream. It's much higher up in the atmosphere, and it usually sits over the pole and minds its own business. Sometimes, though, its strong west winds circling the pole become disrupted, meaning it can stretch from a roughly circular shape to something more like a beam. Or it can split into separate circulations. Or it can disappear temporarily, known as a sudden stratospheric warming. Disruptions usually cause extreme winter weather. Interestingly, recent studies suggest that these disruptions are happening more often, perhaps related to sea ice loss in especially the Barents-Kara Seas area. These winter connections need more research. And then in the summer, a recent sequence of studies links Arctic amplification with extreme summer weather events. Arctic amplification in the summer is focused over high latitude land areas where spring snow cover is disappearing even faster than sea ice. This warming pattern tends to make the jet stream split into two branches over the continents, and this tends to trap summer weather systems and cause them to stall. These stalled weather systems tend to lead to longer and hotter heat waves, more extreme droughts, worsening fire conditions, and prolonged rains that promote flooding. More research is needed here too. By the 2030s, which is not that far away, all these impacts of rapid Arctic warming on mid-latitude weather will worsen and become more frequent, affecting billions of people across North America and Eurasia. The one silver lining of this worsening is that the controversy should start to give way to more clarity as we learn more about these connections and impacts. I wish you the best of luck in your workshop, and thank you again for inviting me to contribute.